In this tutorial we're going to look at the area of squares and triangles. So, start off with the square. And let's just take a simple example. We know in a square all the sides have got the same length. So, let's just say 2 for ease. So, it doesn't matter what they are as long as the units are consistent. So, here we've got the breadth and the height. So, it's the breadth times the height, which is 2 times 2, which is equals 4. Now, let's just say this unit is centimetres, then that will equal 4 centimetres squared, as we're talking in area. If it was metres, it would be metres squared, and so on. Now, a rectangle is very similar to a square, so let's just give this example 4 and 2. Again, it's the breadth times the height, so this time it's going to be 4 times 2, which equals 8, and let's say they're centimetres again, so that's going to make 8 centimetres squared. So with the square or rectangle, think of a square as a special case of a rectangle, and it's the breadth times the height. Now let's look at the triangle. Let's imagine we've got a square or a rectangle, it doesn't matter. If you divide that square or rectangle in half from corner to corner, you get a right-angled triangle. Now that triangle is exactly half the square. So if we think back to the area for a square, that's breadth times the height. Okay, so we've got breadth times the height. Okay, it doesn't matter which one you use, just depends on which one's marked in your worked example or which values you know. With the triangle, right-angled triangle, bear in mind this has to be a right-angled triangle for this case, it's exactly half of a square, and the formula for a square is breadth times height. So it's going to be half b times h. So say this triangle here, you've got, I don't know, 3 centimetres and 2 centimetres. It's going to be half times breadth, which is 2, times the height, which is 3, which is going to make 3 centimetres squared. Okay, so that's fairly simple. Now, if you know the hypotenuse, not the other two sides, you'll have to use Pythagoras Theorem to work out the other side, so you can get work out the area. So, for example, let's do it in another colour. Say you've got a triangle where you know the value of this side here, so you know the value of side x and side y. You need to use Pythagoras Theorem to find the length of side A, and then you can work out the area through the values of y and a. Okay, so it is possible, it's just a bit of a long way round. Now, when you get a triangle that isn't a right-angled triangle like this one down here, any triangle can be divided into a right-angled triangle. So, for example, let's draw this out again. You've got a triangle, just call it equilateral, not an equilateral, an isosceles triangle for now. So, it doesn't really matter, but let's just mark it up properly. We know it's an isosceles, so the bottom two angles are equal. Now, this isn't a right-angled triangle, so it's not quite so easy as half breadth times height, but you can work it out through that. Okay, it's just a bit harder to find the height unless it's given to you in an example. Okay, so here, if we know this value here, or it could might sometimes be drawn like that. Okay, and say that's the height is 5 centimetres. Okay, it can be drawn either way, and the length is, I don't know, 7 centimetres. You can't, and say this length here might be labelled sometimes just to throw you. Okay, you don't need that. You need the actual height from the line that makes a right angle with the base. Okay, so if we extend that out there, that will be a right angle there, and comes to the point. Okay, it could be drawn either one of these ways. But the point is, we don't need that there. It could sometimes put in to trick you. So here, the equation is the same: half breadth times height. So that's half times 5 times 7, and that is going to equal 17.5 centimeters squared. Hope you found this tutorial useful. Please like, subscribe and comment.